So in the last class, previous class, we have discussed about the interaction of spin with external magnetic field. So what happens by the interaction of external magnetic field? Electrons' magnetic dipole moments are interacting with external magnetic field. Similarly, nucleons' magnetic dipole moments are interacting with the external magnetic field. So this interaction gives rise to splitting of energy levels, splitting of spin energy levels. So what is the electron spin value? Either plus half or minus half. So due to this interaction of atom with external magnetic field, the electron spin states will separate from plus half to minus half. So this separation is indicated with delta E for the electron. Similarly, nuclear spin states also. For example, if we consider the simplest hydrogen atom, it in the nucleus we will have only one proton. That is, here is also plus half and minus half. This is also the separation between the two energy levels is also delta E. So our today's class is what is the population of energy levels, that is how these electrons and the nucleons are distributed between these two energy levels we can explain. So again I am repeating. So in the last class we have discussed about the interaction of magnetic dipole moments with the external magnetic field and the interaction of magnetic dipole moments of the nucleons with external magnetic field. Okay, due to this interaction, the each electron spin states and nucleon spin states are splitting up. So these are electron spin states and these are all nucleons spin states. So this separation is delta E. So what is delta E? Delta E is the separation between the two spin states. So in the previous class we have already derived the expressions for delta E by H for electron. So what is delta E by H for electron? Nearly we got 10,000 into 10 power 6 Hertz. So with a external field of 0.34 Tesla. Around at 0.4 Tesla, at the magnetic field 0.34 Tesla, delta E by H, the frequency of the emitted radiation is 10,000 into 10 power 6 Hertz. Similarly, we have also calculated delta E by H for nucleon. So for the nucleon we got 100 into 10 power 6 Hertz at a frequency of 2.3487 Tesla. So in order to know the separation, that is, we need to calculate what are the values of delta E for electron. That is the difference between these two states for the electron and delta E for the nucleons. So from the first equation, delta E for electron. What is delta E for electron? Delta E for electron is 10,000 into 10 power 6 multiplied by H is 6.625 into 10 power minus 34. Units are only joules. So if you consider this term as nearly 6 into, this is 10 power 4 into 10 power 6, that is 10 power 10 into 10 power minus 34, that is 10 power minus 24 joules. The separation between the two electron spin states, we have calculated it as 6 into 10 power minus 24 joules. Similarly, the separation between the two nuclear spin states can be calculated as 100 into 10 power 6 multiplied by H value is 6.625 into 10 power minus 34. So let it be equivalent to 6 multiplied by 10 power 8 into 10 power minus 34, which is nearly 6 into 10 power minus 26 joules. So the separation between the two electron spin states is 6 into 10 power minus 24 joules. The separation between the two nuclear spin states is 6 into 10 power minus 26 joules. So these are the two separation between the two electronic spin states and nuclear spin states. So our aim is to calculate the population. So this population, according to classical theory, the population of energy levels will be given as N upper, that is the population of upper energy state, that means the number of electrons in plus 1 by 2 state divided by N lower state, that is the number of electrons in lower state, is given as exponential of minus delta E by kT. According to classical theory, we can find the ratio of population of electrons or nucleus from upper to lower is equal to exponential of minus delta E by kT. So we already calculated delta E for electron is 6 into 10 power minus 24 joules, whereas for delta E for nucleus is 6 into 10 power minus 26 joules. So let us substitute these two values in this equation, then we can able to find out what is the ratio of population of electrons and the population of nucleus. So delta E for electron is 6 into delta E for electron is 6 into 10 power minus 24 joules, whereas delta E for nucleon is 6 into 10 power minus 26 joules. So then first we will calculate the ratio of upper states, this is only for electrons, by N lower is equal to exponential of what is delta E for electron minus 6 into 10 power minus 24, where K is Boltzmann constant. So Boltzmann constant is 1.38 into 10 power minus 23 joule, and T is the absolute temperature. The room temperature is about 300 Kelvin. So by substituting these values, so Boltzmann constant is 1.38 into 10 power minus 23. The room temperature is 300. Exponential of minus 6 into 10 power minus 24 divided by 3 into 1.38 is nearly 4.2. Here we have 10 square. This is 10 power minus 23. That is 10 power minus 21. So almost we are getting exponential of, so minus 6 by 4, let it be equivalent to 1 multiplied by 10 power minus 3. So what is e power minus x? 1 minus x plus 1 x square and so on. So what is 1 into 10 power minus 3? 0.001. So which is a negligible. So its value is equal to 1. Similarly, delta E of nucleon is equal to 6 into 10 power minus 26. Then N upper divided by N lower is equal to exponential of minus 6 into 10 power minus 26 divided by Boltzmann constant 1.38 into 10 power minus 23, and the room temperature is 300. So which is exponential of minus 6 into 10 power minus 26 divided by 4.2 into 10 power minus 21. That is exponential of, let minus 6 by 4 is nearly equivalent to 1 multiplied by 10 power minus 5. So which can be expanded as 1 minus 1 into 10 power minus 5 and so on, which is simply equal to 1. So in both the cases, for electron and the nucleus, n upper by n lower is equal to 1. So what is its mean? So if n upper by n lower is equal to 1 means n upper is equal to n lower. That is, in an external magnetic field, the electrons and the nucleons will occupy the same number. That is, the population of energy levels, the population of electrons in the upper state is equal to the population of electrons in the lower states. Similarly, the population of nucleons in the upper state is equal to the population of nucleons in the ground state. That is, the same number when the atom is subjected to external magnetic field, these electrons are distributed equally in the ground state and excited state. Similarly, the nucleons will also distributed equally in the presence of external magnetic field. So the population of energy levels is equal for both electrons and neutrons.